As we just discussed, an exponential relation is represented in the form y equals a to the power of x, but a cannot equal 1. Okay? It can't be equal to 1. We'll talk about that after. I'll show you some different graphs. If a is equal to 1, it's not exponential. Okay? And as we just discovered, the ratios of the y values are constant. So the ratios are all going to be equal. Okay, they're the same. We have two different types of exponential relations. One that shows growth and one that shows decay. If the graph looks like an upward curve, okay, so this is our example. If it's an upward curve, it represents a growth because it's increasing, okay? And the way that you can tell from the equation, if the a value, which is the base, right, the base of the power, if it's a number that's greater than 1, it's going to show a growth, okay? It's going to show that it's increasing. So can someone give me an example of an equation that would show growth? Any number greater than 1. Y equals 5 to the power of x. If the graph is a downward curve, it's showing an exponential decay, which means it's decreasing. Okay, it's decreasing. And in the equation, if the equation is written in this form, if a is between 0 and 1. So if it's a number between 0 and 1, it means that the graph will decrease. They can't be negative. So for example, y equals half to the power of x, or y equals 0.4. All of these are values between 0 and 1. So for a, the a value is 1.3, which is a number that's greater than 1. So this is going to increase, and it's going to show exponential growth. B, a equals 0.83. Is that going to be growth or decay? Good. And is it going to increase or decrease? Good. Just think decrease, decay. Decay. The last one, a is equal to 4 over 5. What's 4 divided by 5? Write this as a decimal. 0.8. Is that a number between 0 and 1? Yes. So decay, and it's decreasing. Okay, so we're looking to see which graphs are exponential. What's A? Good. B? Exponential. Is this growth or decay? Good. C?
Parabola.
Quadratic. Good. And is also exponential. Good. Yes, so in this example, we're looking at a relationship between the day of each day. The king is getting grains of rice, right? No, I did not make this question up. On day 1, how many grains of rice does he get? On day 1, he gets 1 grain of rice. How much does he get on day 2?
2.
Day 3?
4.
Day 4. Okay, look here. Shh. Every single day, the amount of rice he gets is doubling. So what's double 4? Double 8, 16. 32, 64. If I were to graph this would be x and this would be y, right? Can you write the y values as a power? 2 to the power of what will always equal 1? 0. 2 to the power of 1 is 2. 2 to the power of 2 is 4, and so on, right? Okay, this is exponential. 2 to the power of 5, 2 to the power of 6. So the equation, y, is equal to what? 2 to the power of x. Instead of having to continue the table all the way up to 15, we can use the equation.
It says it's 16.
Yeah.
999
Okay.
times 10 to the That's a lot.
Okay, how much time do we have? I want you guys working on 2 questions right now, number 6 and number 8 on your own.
Bro, Vanessa.
Made with Doodlecast Pro.